This clip shows how to track between a pad and a via as part of our reminder course on pads 9.3. So we have a simple connection. Let's select the pad first, then F2 to start routing. You can see it's not routing through the center of the via. So we can either, let's change the track width to 0.3. We can either double click and it will finish the route for us. Often that doesn't give a correct result or the desired result. If we do F2, you can see it's only changing in diagonal, so that doesn't quite match the via. We can say A will select the modeless command. Now we can either have AA for any angle, AO for orthogonal, or AD for diagonal. Let's try any angle, AA. Now you see, and route directly to the via. Terminating in a via, select pad, F2 start routing, change width, in this case 0.3 for the ground connection. Now we can do Control left mouse click, terminate in the via, or we can do Shift left mouse click to continue routing after the via. Let's terminate in the via. Keypad Control left mouse click. Let's try that again with continuation. Select F2, change the width, Shift, left mouse click, and continue tracking. We can change the layer, but it's defaulted to top layer. Let's do one more go with continuation on a different layer. Select the pad, F2, change the track width if you like. I'm not going to bother this time. Shift, via, continue, layer, L. Now we can choose the layer. Let's try layer 5. And now we're tracking on layer 5. When checking for errors, using the tools verify, and we're looking for looking for clearance errors, make sure you select the whole board, because clearance checking will only take place on the part of the board that is currently viewed. To select the whole board, select Home on the keyboard. Now we can go and do verify, clear previous errors, clearance checking, start. 45 errors. Most of them in this one area, but there's a few clearance errors in other locations. Looks like looks like the wrong size via has been put in here. So cover this topic as well. So when vias have been added, normally the vias will be added as a BGA via. Let's double check. We can do Control Q, which is a very handy way of effectively selecting the properties. This is a standard via, so it's failing clearance on the adjacent tracking. Change that to BGA via. That should solve that problem. Another way, that's another handy feature of pads, is that when you're looking for clearance errors, and there's lots of them, say here for example, you can just zoom into a section of the board and then do error checking just on that section. That makes it an awful lot easier to sort out. See, all the other errors have gone, to sort out just the errors in a particular location. Here, where there's a clearance error between copper shapes, should be 0.4, and it's measuring 0.375. So we only need to reduce one of the copper shapes by 0.025. Let's check the grid. The grid's 0.1, which is a bit large for the adjustment. So let's change the grid setting. So it's just grid 0.025, 0.025. Check it's changed there. Change the shape. We need to select anything. Now if we move that edge by 0.25, That should resolve that issue. Let's check tools. We're no longer getting any clearance issues between these two copper shapes. In this example, we want to copy a copper shape and mirror it vertically and then locate it in a different place. So we have to select shapes, copy, paste. Now we need to flip it vertically. But there's no vertical mirror. There's just one mirror. And if I mirror it horizontally, it does exactly what it says. Now I rotate it 90 twice, and I've effectively achieved a vertical flip. Now, one last thing to show is that we want to put it into this location here, so that it's a mirror of the shape beneath it. But we also need to attach a net to it, so let's do properties, assign by net, select the pad, apply. Now we can see it's attached to the correct location, and all we have to do is move it into location, its final location. In this example, we've got a copper clearance, so we need to change the copper shape or change the rules. The rules seem reasonable. Copper to copper clearance should be 0.4, it's only 0.25. So here what we can do is cut back the copper, or we can move it. Let's just, rather than move it and then uncover, expose some of the pad, let's keep the entire inductor pad covered and just reduce the copper, increase the clearance just at the pads of the link here. So to change a copper shape, we select an edge using the select anything, split, so you can see it's a room, change the edge, split the edge, and will allow us to just reduce that. Now if we do, we've cleared the error. We're just about to start a design verify process. All the layers have been poured. Now we want to home in on the errors. A quick way to turn the layers off is to use the commands, the modeless commands, but let's just make sure we finish with a flood. So flood applies to the top and bottom layers. Plane connect, it uses the inner layers. So there's two commands that are of interest here. One is pour off, which affects the top and bottom layers, and the other one is the split plane off and split plane display. Pour on, pour off is a toggle, so PO modeless turns the top pour off, PO again turns it on, so we'll turn it off. Now we're going to turn off the copper on the inner layers. We can do it through the display colors. We can turn copper off on all layers. We can individually turn it off in some layers, but a quick way to do it is to split plane off. Turns all the copper off on the inner layers. If we want to turn it back on again after we've made changes, we can do split plane display. One of the best features about pads is the query command, the modeless query command. So here we want to select, there's a clearance error, so I'm looking to see if I can reposition the component that's on the bottom to be on the top. So if we use the tab, we can cycle round components in the same area. I'll try and pick it up. It picks up the wrong component. That's really annoying. But what we can do is we hit Control E. It'll allow us to move this component now as we require. Another useful feature is the modeless query command, where we want to have a look at a component or maybe change its properties. Tab to the component you require, Control Q. In this case, we're going to update the layout by fast forwarding it with a new netlist that's just being created. So here, in this case, we generate an .asc netlist from the schematics. I use using eProduct Designer. Copy the netlist, the ASCII netlist, to the local folder containing the PCB file, and we can do setup, tools, compare ECO. So we're going to use the current PCB that's going to be modified. Now we need to navigate to the ASCII file, goes to the current directory, check the date stamp's correct. Here we can generate an ECO file or not. It doesn't really make much difference. We're not intending to use it. It's copying it to the local directory. These are the main settings. Just check that update's got update original design. The other settings should be as you see here. Okay, let's run that. Okay, so there's some parts which aren't in the library which were introduced to the schematics. So these will need to be resolved first. So we need to sort out these three components. The first one, the capacitor, will be very simple. The other two might take a bit more work because we may need to create or modify a library shape in order to get something that we can use for those. So let's see how we would do that. File library, we have parts and decals. So we'll have to create new parts for those components. First one, capacitor, 33N. We may as well find a capacitor, ceramic capacitor that's similar, 100N0402. We can just copy this, rename it as 3N. And if we just check the PCB decal is SM0402, and there's an alternative decal which is the same 0402 but with round pads. So let's just go ahead with that. And that's that one sorted. When we imported the new netlist as an ASCII file, there were three parts that were missing from the pads library. We've dealt with the first one. The second part is an N-channel MOSFET in a VSON 8 package. The ASCII file contains attributes from the symbol in the schematics. The device field contains the part number, CSD17578Q5A, and the package type defines the decal. Those two have to match exactly. So let's see how we can go about doing it. There's a part in the library that exists, which is also an N-channel MOSFET. There's a different number of pins. It's this PSNM030. We need to make sure that the device field is copied exactly. So let's copy into the new information. Now what that's done is added that part to the library, and it will have assigned the existing decal. Look at the part, PCB decal, we can see it's the SOT 669. We're going to have to edit that. What we can do is also check the pin count. So the new part's got 8 pins, not 5. It uses this pin count as a filter to select parts. Well, that's fine. We can leave this as it is for the moment, and when we finish creating the part, the new decal, then we can come back here and assign it. So let's go OK on that. So here we're going to create the new decal. We'll start off from using one that's similar. In this case, it's just easier. We'll copy that and rename it as. Now we need to edit this in order to modify it to match the datasheet. It's fair enough. We haven't assigned it to any part yet. So whilst we're looking at this, we should be checking the datasheet for the information we need. Here we are, CSD17578Q5A. This is the recommended PCB pattern. So here we're changing the pads sizes. Those 4 have now been done. Okay, let's sort out the main pad now. That looks better. So we can just do a quick check to make sure we haven't messed anything up using Q tool. Yep, 5 is the F10 dimension. 11 dimension. 0.5. Because this pad requires an irregular shape, then the way that this is implemented in pads is to create copper shape and then associate it with the pad. So I've created the castellated copper shape. I just set the origin at one corner and traced around the shape according to the datasheet, which is shown here. So there's nothing tricky or complicated about that. Just select copper and then create the shape. I've checked that the dimensions are between the pads and the shape are correct. So the 1 to 4 have the correct pad dimensions and correct spacing between the pads, and that the overall width F3 matches exactly the copper shape and the spacing between the pads. This is worth noting. If the options in the drafting toolbar are place 2D line, you'd think it would be 1D line, wouldn't you? So we start off with a 2D line, and we're going to put it at the top of the castellation all the way down to the bottom. We want this to be a bar. If we click on this, it will just disappear because we haven't formed the 2D shape. And if we right mouse click, we can select path. You can see I've done this already. If we select path, then when we double click on it, we have the shape that we require. Set the grid 3.1. Then move the edge, we can come out 0.13 on the silk screen. We don't want silk screen violations later. Copy that. Edge of the component and step 0.3. Get rid of that one now, don't need it. The final thing we need to do is associate the new copper shape with the terminal 5. We can just reduce terminal 5 to be a nominal size centered at the origin. And then to associate terminal 5 with the copper, we select terminal 5, associate, select the copper, and now you see terminal 5 is now associated with that copper shape. Now that the decal has been created for the NFET component, the last thing we need to do is link it to the part. So if we go back into the library manager and we select the new component, then we can do edit PCB decal, pin count 5. We made the new component have the same pin count. Let's remove, unassign this assign decal, and let's have a look for the new one, which is this VSON 8. Let's confirm. There's one last component we need to add to our library. Let's have a look at the package. It's a 24-pin QFN with an exposed pad. Now let's have a look and see. In the library we have something like QFN 40. 6x4 is something similar. So what we can do is we can have a look and see where that's used. Let's try the QFN 40. We go into our parts. Our QFN 40 6x4 EPAD. Copy that. Now it needs to be the correct name, the name that is passed in the device attribute. So that's of the symbol. Good. And now we'll modify we'll copy the decal and rename it. and then modify it to match the correct dimensions. 40 6x4 EPAD. Now that needs to be saved with the attribute package type that was passed forward from the symbol, schematic symbol. So let's copy that. Okay. The decal for this VSON VQFN24 has been edited and updated. I found a nice feature to do with renumbering the pads, because the pads were too many pads. Once I'd removed a lot of them, the numbering was discontinuous. Found if you select pad and then use right mouse click renumber terminals, then you can go around and rename all of the terminals in sequence. Interesting thing, if you put a 0 on the prefix, then it adds a 0 there. We know that that then needs to match up with the schematic, the symbol, but it's better if I tend to not have a leading 0, so I just start at 1 on the decal and on the components. So if you set the prefix to 0, suffix to 1, and hit OK, then it'll let you go around each pin in sequence. I'm just going to cancel it because they're already done. So this part's now finished. Save it. All we have to do now is assign it to the component. You really want to exit the decal editor. Oops. Go back to the library. Let's select the part. Edit it. Decal. We don't have a pin count of 41, but that's just a filter. So let's unassign the QFN 40. Change the pin count to 25. Okay, 25 to 41. I'm just going to delete 26 of it. So here we are. We'll have 1 to 25 pins. Go back to decal and do 25. Here's our VQFN 24. Let's assign that. ECO. We'll navigate to the ASCII file. This time there were no library issues, nothing to report. So the changes that to add those components to the library appear to have worked. This block of circuitry is going to replace one of these blocks, and then I'm going to duplicate it. In this case, we're going to copy this entire power supply circuit that's been carefully laid out, so we want to make sure it's copied in its entirety without any changes, and everything is just duplicated. So first thing we do is, it's easier to copy in the PCB layout and then back annotate the schematics with the new refdes information. So first of all, to copy non-netlist items, we need to go into ECO mode. Once we're in ECO mode, make sure everything is selected. Make sure all the layers are turned on, that otherwise there will be missing tracks. Make sure that copper is turned on, otherwise these copper shapes could disappear. So let's select group. Now what we can do is Control C, Control V. Now we can do Shift relative, no gap, 0, say 30. Spacebar. Now we can have a look what's missing. The thing about pads is always something missing. So we would expect that the nets are all now undefined. So it's copied the shapes, but it's the nets are undefined until we do the forward annotation with the schematic, with the ASCII net list. So we've got no ground pads. It's actually removed all the ground vias, all the power vias, ground vias, all the connections to ground here, all the connections to power there. It's kept some ground vias, so, and the thermal vias are all missing as well. They were all previously converted to stitching vias. I don't know how to preserve those when I copy circuitry in the PCB layout. It'll probably take me 10 or 15 minutes to go back and fix all the things that are missing, but it's still worthwhile. Okay, so to achieve closure on this refresher video, I thought we would just look at the completed layout. So I've just loaded it up into pads 9.3. I'm going to select home to view the entire board. Before I do any checks, I'm going to make sure all the layers are turned on. So previously the ground layers were turned off. Now it's a 14-layer board, all the layers are turned on. Let's pour the copper. So we'll start with the outer layers, outer layer flood. Don't need to worry about those. Let's connect the planes. Let's hit home again since I've zoomed around, and we can do our verified checks. We start with the ones I normally do. I would normally do with clearance on its own. Good. Connectivity, of course. And I usually finish it off with a plane check, which seems to be a combination of both of them. Perfect. Well, I hope you found this video interesting and useful. If you have any feedback or requests, you can message me directly. My email is on the final slide.